Welcome to the AIM booth here at Productronica. I'm joined by Tim O'Neill, who's the Technical Marketing Manager. Nice to see you. Yeah, good to see you. So we've got a couple of new products we want to talk about today, Tim. The first of which is, of course, your REL 61, which is an alloy that apparently is good for voiding. And I'm saying an alloy that's good for voiding is versus a flux that is good for voiding, and it's also good for hole fill. What are the properties in this alloy that make it good for these applications?
So what we've learned is that we developed REL 61 as a low-cost alternative to SAC 305. We wanted a product that offered the performance characteristics of SAC 305 at a lower cost. Yep. Some of the other low and no silver alloys, there's a compromise. Yes, you get the reduction in cost, but the performance in terms of barrel fill may not be as good as SAC 305. The addition of silver promotes wetting. Yep. We've developed this alloy to provide the same degree of wetting performance as a SAC 305 alloy while saving the user money. We expect REL 61 will be widely used in wave and selective soldering, where the bulk of the alloy is the cost driver. Yep. But we've also discovered in our product development that because of this improved wetting performance, that it actually reduces voiding and surface mount. And if you think about it, it actually makes sense. If your flux vehicle is more aggressive, it tends to reduce voiding. Yeah. What does an aggressive flux vehicle do? It improves wetting. If you have an alloy that in and of itself wets better, it's effectively giving you a little boost, but on the alloy side as opposed to the flux side. So we're very excited about the results that we've been getting from the field. We have over 150 samples in the field of the REL 61, and all of the data that we've been collecting is what's been reflected from our lab work as well. So we're very excited.
And what particular applications have you aimed this product at?
Well, the REL 61 is a universal product. REL 61 has reliability characteristics very similar to SAC 305. Its thermal cycling characteristics are actually a bit better than SAC 305. One of the deficiencies of SAC 305 is that when the alloy gets hot and cold very frequently, the metallic structure of the grain actually coarsens, and it can reduce the mechanical strength of the alloy quite significantly. REL 61 has been developed incorporating a bit of bismuth, which is now something that I see here at Productronica. A lot of my competitors are offering alloys that probably contain some bismuth. We're all being a bit coy about what's actually in there and how much. But the RoHS 2, or the full implementation of RoHS, which will happen in July of 2019, virtually eliminating the risk of bismuth-lead combination, is giving us bismuth as an option again. Yeah. So that's basically the strategy we see the industry moving in.
Yeah, I've seen quite a bit of it around the show too, I agree. Yeah. Now, you've got another material here, the REL 22, which is a sort of higher range material for premium range material. Okay. Presumably because it's got a slightly higher silver content, but it's for high REL applications like automotive. Can you tell us a little bit about that?
Sure, I'd be happy to. So REL 22 was developed in response to the issue I mentioned earlier about SAC 305's degradation in mechanical performance after exposure to thermal cycling. We believe that as electronics become more capable in a smaller space, one of the byproducts of that is going to be heat. So industries where you're jamming a lot of technology into a small space are going to get hot and cold. Yep. Not to mention, as electronics become commonplace in harsher environments, there's going to be more requirements for more durable circuit boards. REL 22 is a silver-bearing alloy. As I mentioned earlier, it's got a silver content similar to SAC 305, so it's not a low-cost alloy. It is a premium product. And it's going to offer solder users a material that's going to have twice the mechanical strength of a SAC 305 solder joint in a harsh service environment, which is very attractive to a lot of applications.
Absolutely. And I think one of the key things as well is that it doesn't mitigate tin whiskers or creep or these types of things, which are really important for the automotive industry.
So tin whiskers was a concern when everybody switched from RoHS. Probably one of the biggest concerns was, what about tin whiskers? Well, we've learned a lot about solder alloys and tin whiskers. And again, having other alloy options available, or other elements available to us to alloy in these new materials, is reducing that risk of tin whiskers. AIM has been able to reproduce tin whiskers in the lab. We have a very repeatable test. So we're able to compare SAC 305 and other high tin alloys to the new REL alloys. And the REL alloys have consistently demonstrated a lower propensity for tin whisker formation.
Really?
Yeah. So with the expiration of RoHS again, it's going to make it more difficult for high reliability manufacturers that were going to rely on lead, military or quasi-military applications, who are very concerned about something like tin whiskers, an option to explore that could make that risk much lower.
Yeah, absolutely. Okay, great. But I mean, obviously this is a premium product, as you said, so it's going to be a little bit more expensive, but of course the performance is going to match that.
That's what we expect.
Yeah, great. Tim, it's always nice to catch up on new products that when you bring them to the market, and thank you for joining us today.
Trevor, it's always a pleasure.